Imagine a small village called Serverpur, population 500. There's one main road, one market, one water tank. Everything works perfectly. The mayor is happy. Residents are happy. Life is good. Then the government announces Serverpur is becoming the new IT hub. 5 lakh people are moving in over the next 5 years. The same one road completely jammed. The one market 6-hour queues. The water tank empty by 8 am itself. The mayor now has exactly one job: make Serverpur scalable. And that is the question every engineer faces when their app starts growing. Can your system handle 10 users? Yes. Can it handle 10 million? That depends entirely on the decisions you make today. Let us get back to our story. Serverpur's main market road is jammed. The mayor calls a meeting. First idea on the table: let's widen the road. Dig it up, expand it from 2 lanes to 6 lanes. Same location, same road, just more powerful. This is vertical scaling. You take your existing server and make it stronger. In tech terms, this means upgrading the CPU to a faster processor, adding more RAM so the server can hold more data in memory, or switching from a slow spinning hard disk to a fast SSD. The advantages are real. Vertical scaling is simple, no architecture changes, no code changes. You just get a bigger machine and restart. And because everything still runs on one machine, there is no network communication between servers. So latency stays low. But here's the hard truth. You cannot widen a road forever. At some point, you hit the city boundary, other buildings, or a river. You cannot go further. In tech, that's the hardware ceiling. The biggest machine AWS sells still has a maximum configuration, and there's a painful operational problem. While you are widening the road, it is closed. Upgrading a server means taking it offline. That's downtime. Your users can't access the app during the upgrade. And critically, one machine is one point of failure. If that machine crashes, everything crashes. There is no backup. So when does vertical scaling make sense? When your app is tightly coupled and can't be easily distributed. When your latency requirements are so strict that inter-server communication is not acceptable. When you need to scale fast right now without touching any architecture. Think of vertical scaling as your first move, not your forever move. One thing I want you to know about is cost. This catches people off guard. Doubling your server specs does not double your bill. It triples or quadruples it. Cloud pricing is non-linear. A 64-core machine costs significantly more than 2x the price of a 32-core machine. That's why horizontal scaling often becomes more cost-effective at scale. Now Serverpur's engineer proposes a different idea. Don't widen the existing road. Build more roads. A ring road, a bypass, an expressway. Now we have 3 parallel routes. Traffic is spread across all of them. The city keeps growing. Build another road and another. There is no ceiling because you are not making one thing bigger. You are multiplying. This is horizontal scaling. Instead of one powerful server, you add more servers, all running the same application, sharing the load. Netflix is the best real-world example of this. As more users start streaming in the evening, Netflix does not frantically upgrade one chain server. They add thousands of servers to their clusters automatically. Traffic drops at 3 am, they scale back down. Zero downtime, always on. The advantages are significant. No ceiling. Theoretically, unlimited capacity. No downtime to add capacity. You bring new servers online, while existing ones keep running. And critically, no single point of failure. If one server crashes, the other 3 keep serving users. But horizontal scaling is not free. The moment you have multiple servers, you need something to decide which server handles which request. In Serverpur, that's a roundabout or traffic signal at the junction telling each car which road to take. In tech, that's a load balancer, and we have a dedicated video on it. And there is a critical architectural requirement. Your application must be stateless. I'll explain exactly what that means in the next slide. But for now, understand that not all apps can be horizontally scaled without redesigning how they work. Here is how I think about the choice. Horizontal scaling is harder to set up, but better in every way once you have done it. It's the difference between widening one road and building an entire highway network. Imagine Serverpur has toll booths on every road. In the stateful version, each toll booth attendant keeps their own private notebook. When you come through, they write down your car number, your payment history, your frequent routes. That attendant knows you. Now imagine you switch lanes. The new attendant has no notebook, no record. They look at you blankly and say, "Who are you? I have no record of this vehicle. You are denied. The system is broken." This is a stateful server. It stores your session, your login, your cart, your preferences in its own local memory. If your next request goes to different server, that server has no idea who you are. You are logged out. Your cart is gone. In stateless version, there is a central registry maintained in a shared office that all attendants can access. When you arrive at the booth, they check the shared registry, verify your details and wave you through. Any attendant, any booth, any road, same answer. This is stateless server. It stores nothing locally. Every request contains a token, usually a JWT or session ID. The server reads your session from a shared external store, Redis or a database, processes the request and forgets about you. The result: any server can handle any request from any user at any time. Rule: keep your app logic stateless. Push session state to an external store. That's it. That's the prerequisite that makes horizontal scaling possible. Here is where modern cloud infrastructure gets genuinely impressive. We said horizontal scaling means adding more servers, but who decides when to add them? Who decides when to remove them? In the early days of the internet, this was a human job. A DevOps engineer would watch the traffic, see a spike, and manually spin up more servers. But today, the system does it automatically. This is called auto scaling or elasticity. Cloud platforms like AWS, Google Cloud, and Azure monitor your servers in real time. CPU usage crossing 80%, they automatically spin up 5 more servers. Traffic drops at 3 am, they automatically shut down 10 servers you no longer need. Look at this traffic pattern. Morning is light, then 9 am hits. People open Instagram, Twitter, shopping apps on their way to work. Traffic spikes. The system adds servers. By evening, peak, maybe 20 servers running. Midnight, traffic falls. Servers scale back to 3. You pay only for what you use, not for 20 servers running idle at 3 am. Think about what this means for Indian apps. IPL match starts. 50 million people open the streaming app simultaneously. The system automatically scales up. Match ends, scales back down. No engineer needed. No downtime. No overpaying. AWS autoscaling, Kubernetes HPA, horizontal pod autoscaler are real tools. You define the rules once, something like scale up when CPU hits 75%, scale down when it drops below 30%, and the cloud handles the rest. Elasticity is horizontal scaling on autopilot. Every system you have ever used, Instagram, WhatsApp, Zomato, Swiggy, went through this same journey. Not one of them was born at scale. They all started exactly here. Stage 1, 1 to 1000 users. One server, it does everything. Serves the web pages, runs the app logic, stores the data. It is cheap, simple, and it works. Don't over-engineer here. Instagram, even in 2010, ran on a single server for its first million users. Stage 2, 1000 to 10,000 users. The server is starting to feel the load. First move, vertical scale, upgrade the machine. Second move, separate the database onto its own server. Your web server and your database have different resource needs. The web server needs CPU and fast response time. The database needs RAM and fast disk access. Splitting them is the first architectural decision you make. Stage 3, 10,000 to 1 lakh users. One server is now both a bottleneck and a single point of failure. If it crashes, your entire app is down. Time to go horizontal. Add a load balancer and 2-3 app servers behind it. Now if one server crashes, the others keep serving and you can handle 3x the traffic. Stage 4, 1 lakh to 1 million users. Now the database is your bottleneck. Every request hits it. Time to add a cache layer. Redis sitting in front of the database, serving frequently requested data from the memory in microseconds. Add read replicas for database reads. Add a CDN so that images and videos are served from the edge servers close to the users. Stage 5, 1 million users and beyond. Now we are dealing with a global scale. Your database is too large for one machine. Time to shard it. Splitting it across multiple servers by using user ID or region. Your app is one giant monolith. Time to break it into microservices so that each team can scale their piece independently. And you deploy in multiple geographic regions, servers in India, servers in US, servers in Europe, so that every user gets a fast response regardless of where they are. No system was born at stage 5. Every great system earned it, one bottleneck at a time. And the most important lesson from this journey, scale what's actually broken. Don't build for 10 million users when you have 1000. That is premature optimization and it will slow you down. 6 things you learned from this video. Screenshot this if you want. 1. Scalability is handling growing load by adding resources. Not magic, not hoping. Intentional engineering. Vertical scaling. Bigger machine. It has a ceiling. It causes downtime. It's your first move, not your forever move. Horizontal scaling. More machines. No ceiling, no downtime. But your app must be stateless and you need a load balancer. Make your app stateless. Push session state to an external store like Redis. This is the single most important architectural decision that enables horizontal scaling. Auto scaling lets the cloud manage your capacity automatically. You pay for what you use. IPL traffic, handled. 3 am silence, scale down. This is the most counterintuitive one. Don't over-engineer from the start. Start simple. Find your bottleneck, scale the specific thing. Every great system started as a single server. In the next video, you are going to learn about availability and reliability. Thank you.